Okay, see Lindelof videos, sketching in a quadratic in standard form. Remember, standard form is when we get this thing that looks like this. Looks like y is equal to ax squared plus bx plus c. And I hear a lot of instructors saying, start with the x-intercepts. Well, what if they don't exist? How could you still sketch this thing right? So you have to have a method here. So my method is this. I just look for these pieces, a, b, and c. So I have a is equal to negative 1, because hopefully you can see that there's this negative 1 right here. B is equal to negative 2, because there's this negative 2 right here. And C is equal to negative 1, and hopefully you can see there's a negative 1 right there. So, okay, so then I'm just going to start making some evaluations, like what conclusions can I draw? Well, I know that because we've talked about this a lot, if the A value is negative, then we have a frowny face. We have a maximum parabola, so we know that it's going to take this general shape. That's a really important piece of information. I also know that the y-intercept, when the function is in this specific form, the y-intercept is equal to 0c, so 0, negative 1. That helps me. What am I going to do with b? Well, I know that this vertex piece right here, that the x value of this vertex, this x value right here, is equal to the opposite of b over 2 times the a value. So all I'm going to do is go back and fill in the blanks. We know that our b value was negative 2, so I'm going to put in this negative 2. There's my negative 2. We know that our a value is negative 1, so there's my negative 1. Negative times a negative is a positive. 2 times a negative 1 is negative 2. And we know that, negative 2. We know that positive over negative is negative, and 2 over 2 is 1, so we get negative 1. So what do we get? We got this point is negative 1. Then I'm going to take my function, and I'm going to plug that in. I'm going to say, okay, I have this. It said x says clearly right here that x is negative 1. So x is negative 1. It says here that we square it. So negative 1 squared minus 2 times negative 1 minus 1 is equal to, and we do all this math, this comes out to be 0. So here we got this point now. So what are we going to do with all this stuff that we got? Well, what I'm going to do is take draw in my Cartesian plane. So here's my Cartesian plane. And I'm going to start putting in the stuff that I know. I know that the vertex was at the point negative 1, 0. Well, here possibly is that point negative 1, 0. So maybe this is negative 1, 0, negative 1, 0. We also knew, because we did this research, that the a value is negative, so this thing takes on this shape here, right? It's concave, it's a maximum value, so it looks like this. So I know it's going to do this also, don't I? From here, I know some other stuff. I know that the y-intercept, because we gathered that piece of information, the y-intercept is at 0, negative 1. So this is definitely 0. Maybe this is 0, negative 1. So 0, negative 1. Maybe I'll move that down a little bit. Here, this is 0, negative 1, because it doesn't matter. This is definitely not the scale, right? From there, we know this, that if we know that parabolas are symmetrical, so we can cut this thing in half, and we can say that our axis of symmetry is the line x is equal to negative 1. Why negative 1? Because it passes through that point right there, right? And this is our axis of symmetry. Okay? So there's our axis of symmetry. We also know that our function does this, that our function is increasing from here to here, isn't it? And decreasing from here to here. And if I had more time, I would go over this with you, but this is our increasing interval, and this is our decreasing interval. So look, I hope this is helpful. Just as a basic idea, remember that given a parabola, given a quadratic function, there are lots of ways to sketch, even if we don't have x-intercepts. Here we have an x-intercept, but all right. Hey, if you haven't already subscribed, please subscribe, and your comments are always welcome. Thanks for the support, you guys.